There it is. How we doing, guys? We are ready to start chapter 3, parallel and perpendicular lines. So, not that we haven't talked a little bit about this already, but
Yep.
we're going to go into it pretty deep, actually, especially the parallel lines. We're going to spend a lot of time on parallel lines, and so just noticing the diagram down below with the two kind of reddish orange lines, lines A and B. Those are parallel to each other. And we know that they're parallel in the diagram because they have the two little triangular or arrowhead type markers on them. And so they either have to be marked that way or they have to tell us in the instructions of the problem that those two lines are parallel for us to see that, for us to know for sure that they're parallel. And so we're just going to go over lots of properties of parallel lines.
Right. I mean, real quick, just to follow up from last chapter, just looking at that diagram from those two triangles, I can deduce that line A and line B are parallel. So because of those triangles, if those triangles are there, then I know that those lines are parallel.
Yep.
And that's kind of that follow up to what we just learned, guys, in last chapter.
Mm-hmm.
And then that R over there in the corner, you got to remember what that means. That means plane R, so that both of those lines are in the same plane. Just remember that.
Yeah.
Okay?
So the blue plane there doesn't have a point by it, so it's representing that plane.
Yep.
So the first section is titled Identify Pairs of Lines and Angles. And once we identify these pairs of angles, especially, we use them the rest of the year.
Yep.
So you got to catch these names as quickly as possible. The sooner you know them, then the easier the rest of it is. So, again, in this diagram, we have parallel lines. Now, there's a specific word here, the word in blue, that most of you don't think about when you say what are two parallel lines. Most of you say parallel lines are two lines that don't intersect. But we have to be a little bit more specific with that. We have to say two coplanar lines that do not intersect. They have to lie in the same plane and never hit each other to be parallel. And the reason for that is because of the next definition that we're going to have. So parallel lines, same plane. All right? And so we do have another kind, because what about that green line?
Yep.
The green line doesn't hit either one of those two, but it's not parallel to either one of those two.
It's all skewed up.
It's all skewed up. So that's our definition. Sorry, A and B, we already talked about this, but A and B are the parallel lines in that particular diagram. And so we have this definition. The green line, compared to the other two, are skew lines. And so they're never going to intersect either. The green line and the two orange lines, or red lines, will never intersect, but they're not parallel either. And that's because they're not coplanar. They do not lie on the same plane, and they don't intersect. And we can look at around the room and see lots of skew lines.
Yep.
Too. And so we'll do that in the classroom. Tomorrow we'll talk about skew lines in the classroom and look at ones that just never intersect each other, but they would never lie on the same wall either. So make sure you understand what skew lines are.
And just to go over this, guys, some of you may struggle if you look back up at that little box up there that says A is parallel to B. You're going to see worksheets. You're going to see questions they're not going to say the word parallel.
Right.
They're just going to show that, and you have to understand. You have to be able to read that as A is parallel to B.
That's true.
So whenever you see an equal sign standing on its head, that means parallel.
Yeah. It's just another symbol to represent that.
Yep.
Just like we had our upside down T, it looked like two perpendicular lines. Well, it is perpendicular lines.
Yep.
And this one looks like two parallel lines. That's the symbol for parallel lines. So, all right. And so we have two more. Or no, I'm sorry. We're going to do this example in class.
Yeah, so look at this box right here, and then there's two questions that are going to come up. First thing we want you guys to do is to be able to name three lines that run parallel to AD. Okay?
That should be line AD. I don't know where the little symbol is, but
so yeah,
line
so we
AD.
want three lines that are parallel to line AD. And then after you find those three, so find AD there, find three lines that are parallel to that. Then after you do that, we want you to name two lines that are skew to BC. Now they only want two, but how many are there, Mr. Scritchfield?
I don't know. I'd have to count.
I see.
To BC?
Mm-hmm. I see four.
Four.
Personally. Yeah. So we're only asking you. So for extra credit, see if you can find all four.
Yeah, four. Yes. Yep.
Yep.
Yeah.
So see if you can do that.
I was going to say something here. Oh, this looks like a room. And so
Yeah,
we were just
totally.
saying that we'll talk about skew lines when we get back in the classroom, but this does look like a picture of a room, and so You have to be able to see this picture. It's a little bit weird. D is the point that's kind of furthest out here, and H is the opposite corner. It's the farthest corner back there in the bottom of the room. So you got to see a little bit three-dimensionally here to see what's going on there, but as long as you can see that. So I have answers for those two questions in class tomorrow. All right. Our PowerPoint is being very slow here.
All right, so parallel planes. Well, if we got parallel lines, it makes sense to me that we've got parallel planes. So, I mean, it's real easy. Two planes that do not intersect. Now, when you look at the label there, guys, remember we label a plane as an uppercase letter with no point attached to it. So that reads plane X is parallel to plane Y. Okay? I mean, you know, just think of it as a piece of paper in this hand, or this hand right here, and this hand right here. My hands can be considered planes. I can move them as long as I'm moving them wherever I want. My hands are never going to touch, and they're parallel. So, same idea.
Think of the roof or the ceiling of a room and a floor of the room.
That's right.
Those are always parallel planes. Front wall and the back wall, two side walls of a room, those are always parallel planes. We don't have anything, there is no such thing as skew planes.
No.
No. Two planes are either going to intersect or they're not going to intersect.
That's right.
They're either parallel or they're going to hit somehow.
Right.
So.
And then we have line perpendicular to a plane is perpendicular to every intersecting line in the plane. Now, this one really, I have an easier time explaining this one where I can take a ruler over a plane and kind of spin the ruler around. But
Yeah.
But guys, if you look at this diagram, you see line ST there on the top one, and then you see that WU, line WU there is kind of going up and down, and it crosses over and makes a perpendicular with ST there at U. You could pretend that ST was part of a compass. You could spin ST, 180 degrees. No matter which way you spun it, it's going to be perpendicular with line WU as you go through there, if you can visualize that. So just in your head, look at ST and spin that line mentally 360 degrees. And as you do that, keep in the fact in your mind also that WU is perpendicular to ST, and it'll always stay perpendicular no matter which way I spin that line. I mean, that's really what it says.
And that would have to be given to you. It's not really given in this diagram that
Right.
WU is perpendicular to ST, but assuming that that's true, because that's what the definition is saying here, assuming that it is perpendicular to that one line, it would be perpendicular to every line that hits at point U on that plane.
Yep.
So here's our, is this our big one?
This is going to be the focus part of the lesson here in the next one.
Okay. So let's make sure that we just get a picture of what's going on here.
Yeah.
Because we're going to use this diagram millions of times here. So we just have two lines, any two lines. Now a lot of times we're going to use this diagram where the lines are parallel, but that's not always the case. So these specifically are not parallel. They're going to eventually hit each other. And so we're just going to take two lines, M and N in this case, and we're going to take another line and make that line hit the other two lines. It's going to intersect both of those lines somewhere. And that line that intersects two other lines, or at least two other lines, has a very specific name, and it's called a transversal. Okay? And so that transversal has to hit at two or more coplanar lines at different points. And that different points is pretty critical. Again, these two lines can't be intersecting each other at the place where the transversal comes across. They have to hit it at two different places. So a transversal is any line that hits two coplanar lines at different points. All right? And so here's a picture of a transversal. So it's just another line coming in and hitting those two lines. Okay? The numbers may have been confusing there for a second, but the numbers are just representing the angles that end up showing up. And notice anytime you have two lines cut by a transversal, you get 8 angles. You get 4 on one of them and 4 on the other. Now what's critical to see here is that there's a set of 4 on the top line and there's a set of 4 on the bottom line. And you have to distinguish between those two sets of angles. The fact that 1, 2, 3, 4 in this diagram, they all share a vertex point with line M. 5, 6, 7, and 8, they all share a vertex with line N. And so all those angles share the same vertex. All of 1, 2, and 3, 4. 1, 2, 3, and 4 share a vertex. And they're separate from each other because that transversal hits the two lines in two different points. It's critical that you see the separation there for what we're going to talk about here. And so we just have some common names for pairing up some of these angles. And I know it seems like maybe our goal is to confuse you guys, but you need to keep these completely separate from the other pairs that we've had. You know, we've had linear pair, we've had supplementary, we've had complementary, we've had vertical angles, all those different kinds of angles that we've had. We're going to give you 4 more different types of angles here, and you have to keep these names separated from those.
Adjacent's important here too,
Adjacent is important, yeah.
especially with alternate interior. Adjacent is kind of, and consecutive interior.
Yep.
Or well, you'll see in a minute here, guys.
Yeah, so our first kind is that we need to break these names down though.
Yeah.
And so anytime you see the word alternate when we're talking about a diagram like this, guys, we're talking about the transversal. And what alternate means is that one angle is on one side of that green line and one is on the other side of that green line. And so you can kind of think of it as opposite sides. Alternate means to alternate between sides here. So alternate means one's on one side, one's on the other. Now again, we're always assuming that we're talking about, when we're talking about these kinds of angles, we're always assuming we're talking about one of the angles on the top, one of the angles on the bottom. And so alternate angles are one's on one side of the green line of the transversal, one's on the other. Interior, we need to talk about the 2 lines being intersected here. So line M and N, if you can kind of think about those as creating a box, then angles 3 and 4 and 5 and 6 end up being inside those 2 lines. 1 and 2 and 7 and 8 end up being outside those 2 lines.
Which we call the exterior.
Which we call the exterior. So again, hopefully you know the definitions of those words. Interior means inside, exterior means outside. And so this literally means alternate, one on one side of the green line, one on the other, but both inside the 2 yellow lines here. Okay? So to come up with examples, Mr. Bigelow, what would be an example of one of those then? A pair of those. It's always in pairs, guys.
So if I look at this, I'm looking for on the inside of the 2 lines and on opposite sides of the green line. So I'm going to say angle 5 is an alternate interior with angle 4, and angle 3 is alternate interior with angle 6.
Okay. So 5 and 4, one's on the left, 5 is on the left side of the green line, 4 is on the right side of the green line, but they're both inside the yellow lines. So those are alternate interior. 3 and 6, 3 is on the left side of the green line, 6 is on the right side of the green line, but they're both on the inside. And so those are alternate interior angles as a pair.
Another way I kind of look at this too is if you look at angle 3 and angle 6, those are both acute angles and they're on the inside. So they're kind of similar. They may not be the same, but they're kind of similar. And I look at angle 5 and I look at angle 4 and I'm going, those look pretty darn obtuse to me. So those are kind of similar as well. And that might be another way to maybe help you differentiate on alternate interior is the 2 obtuses on the inside and the 2 acutes on the inside have some sort of relationship.
Typically match up.
Yeah.
Yeah. And so that's what they're asking for here. They're asking for you to come up with the pairs of angles that form alternate interior.
Our angle signs didn't come up.
Oh, were they there before?
I don't know.
I don't know. I think we're just numbering them.
Okay. Oh, gotcha.
So angle 3 and angle 6 and angle 4 and angle 5, just as Mr. Bigelow said. All right. Now, compare that name to the next one here. Want to run with that one?
All right, so alternate exterior, guys, is, well, it's almost the same thing. If we take Mr. Scritchfield's interpretation of alternate, that means we're going to be on opposite sides of the green line. And exterior, if interior was in between the 2 lines, then exterior is going to be on the outside of those 2 lines. So when you look at this, alternate exterior is really not much of an extension from alternate interior. We're just going from in the middle to on the top and on the very bottom of those 2 transversal lines. And once again, I'm going to use my logic of, angle 1 is on the outside and it looks kind of obtuse. So when I look down at the bottom there, angle 8 is also obtuse and it's on the outside. So I'm going to say that there's a relationship of alternate exterior angles between angle 1 and angle 8. And then when I look at angle 2, it looks kind of acute. Angle 7 looks kind of acute. So I'm going to say there's a relationship for alternate exterior angles between those 2 because, they're both acute and they're on the outside. So, really that's a couple different ways to really look at it. You can understand what alternate exterior means, or you can just kind of look at size maybe to help you guys if you understand what exterior means. So if we look at that, angle 1 and 8, okay, so angle 1 is on the upper left, and angle 8 is on the bottom right. So they switch sides, upper left, lower right, exact opposites. Angle 2 is on the upper right, and angle 7 is on the lower left, opposite sides, and on the outside. So another way to think of that too.
Yep. Yep. Okay, so make sure you have those two. Those kind of go together in a way. They're both alternate. In fact, they're the only two that have alternate in their names. Interior, inside, exterior, outside. So catch the pattern with that. Okay. And then we have, for our next types of pairs of angles, called consecutive interior. So obviously they're still between the two yellow lines as being inside the two yellow lines, but now they're consecutive. So now they're on the same side of the green line, same side of the transversal, not on alternating sides. And so if we look at our interior angles, 3, 4, 5, and 6 are the ones that are in between the two yellow lines. If we need ones that are on the same side of the transitive, that would be 3 and 5, and that would be 4 and 6. So 3 and 5 are both on the left side of the transversal, but they're interior. 4 and 6 are both on the right side of the transversal, but they're interior. And so those are consecutive interior, or we also call them same side interior.
That's what I was going to bring up. I would say, guys, right underneath the word consecutive interior angles, just write same side inside.
And we'll take either one for
Yeah.
an answer. If you want to call them same side interior, that's fine.
Yeah, same side inside, same side interior. Makes it a lot easier to remember versus consecutive. Because I hear consecutive and I go 3, 4.
Right,
7, 8.
consecutive numbers,
Yeah.
and that has nothing to do with
It
it.
has nothing to do with it. Don't make that mistake. It's same side inside.
Yeah, yeah. So the pairs that come up are 3 and 5, 4 and 6. Okay, and our last one has a name all to itself.
Yeah, and
It doesn't match up with any of these.
this one you kind of have to take a different approach to how you look at it too. And this one is corresponding angles. And corresponding is, if you were to define that, kind of like, to me, I think of it's kind of in a similar location. And so
There's a one-to-one correspondence here going on.
yeah, so you got kind of an acquaintance with somebody, and it's very close, but maybe not necessarily right next to one another. So corresponding angles, guys. If I could give you an idea here, it's kind of like four corners of a street. You've got, if you look at angle 1, it's on the northwest corner of the street. If you look at angle 2, it's on the northeast corner of the street. Angle 4 is on the south east corner of the street, and angle 3 is on the southwest corner of that street, where line M and transversal meet. And then if you go down to the bottom, angle 5 is in the northwest corner of that part of it. Angle 6 is on the northeast corner. Angle 8 is on the southeast, and angle 7 is on the southwest. And so the idea of corresponding to me is same spot, different location. So if I look at angle 1 is in the northwest corner. And so when I go down to those other 4 angles down below it, I'm looking for the other angle that is in the northwest corner. And so which one would that be, Mr. Scritchfield?
That'd be 5.
Yeah, it'd be angle 5. And so if I look at the northeast corner, okay, so now the northeast corner is angle 2. And so I come down to the other transverse, or the other intersection down there, and angle 6 in the northeast corner. And so that's kind of a way. And so if we can look at all these relationships here, maybe.
And guys, there's lots of ways of looking at these, the corresponding angles.
There we go.
There we go. Hopefully
It might come
move
move
slides.
one more again. So
Yeah.
what's your interpretation of Mr. Scritchfield?
Well,
when you
I
think of
look
it?
at corresponding. First of all, it does not have alternate in the name.
Right.
So because it does not have alternate in the name, you don't switch sides of the transversal like you do with those. You stay on the same side of the transversal. And what I think about with corresponding is just sliding. So let's look at angle 2 for an example. If you take angle 2, I can just slide it down right on top of angle 6. It's the same exact position, like you say, it's the same corner of the intersection. I can take angle 3, for example, and slide it down to the bottom setup there, and it lands on number 7. So corresponding angles, they slide down on top. They remain in the same position here. And so again, either by name, does not have alternate in it, so it stays on the same side, but it's the same angle at the other intersection, or you can think about just sliding it down or sliding it up, whichever way you're going. Okay? So I know this may seem confusing, but you have to know these. And once you get a pattern down of knowing them, then hopefully they become pretty easy.
And once we start doing parallel, usually the light bulb goes on pretty good because
Yeah.
it's much easier to see when the lines are parallel.
Yeah. And that's what we spend most of the time on.
Yeah.
So, all right. So pause it however long you need to make sure that you catch that, but we will do example after example of these. You need to make sure you catch these.
And I think you make a good point. I would just pause this and try to look at this and say, why are 3 and 6 similar? Make a connection with why 3 and 6 are alternate interior. Make a connection with why 1 and 8 are alternate exterior. Make a connection with why 3 and 5 are consecutive interior. And then look at all those corresponding angles and try to figure out a way that you can understand why they're corresponding. I mean, I
What
think
they have
that's
in
really,
common, yeah.
really what it takes to get good at this is you have to spend some time just manipulating that drawing in your head and kind of unpacking what they're asking you to do.
Yeah. And we're going to be looking at these in more complicated diagrams later, so you got to get them in the basic form right now.
Yeah. It's one of my favorite things in geometry.
It
Is
is.
transversal.
Yeah, they come right through and they're pretty straightforward. So, all right. We're going to look at another example of something we're going to do in class. Yeah, now don't freak out on this diagram that we just made that massively complicated compared to the last one. But we're going to look at this and we're going to ask you to list some of those types of angles out of this. Okay, so we're moving on. We're just going to do that in class. So, and I believe this next one is our last slide for this section. Not a ton of definitions here, but the ones that we have are
Pretty
important.
significant, yeah.
And so, up with us here. There we go.
Uh-oh.
Uh-oh, one too fast. So we have two postulates. One called the parallel postulate. And again, these are going to be very similar, so make sure you separate them by name. Parallel postulate. So I don't know if you can see it, but there's a red point above that yellow line there. And so given a line, the yellow line, and a point, the red point, not on the line specifically, it can't be on the line, there exists only one parallel line going through that point. Probably a better way of saying that. There exists exactly one line parallel to that line that goes through that point. And if you think about that, how could I draw another line besides the one that goes through there? There's one that's parallel to the bottom line. How could I draw another one that would be parallel?
Right.
If I change the angle like going through the screen here, that's not parallel anymore because they're not coplanar.
It's skewed.
It's skewed.
Yay!
Yeah. So there's only one.
Only one.
Only one possibility of having a parallel line go through that particular point compared to that line.
It's like the Highlander. There can be only one.
That's right.
You ever watch that TV show?
No.
Oh, man.
But if you have, I guess that makes sense to you. I don't know. Okay, so we got one last one here, right?
Yep. So parallels, brother.
Similar but different. Yeah.
So now we've got the perpendicular postulate. Instead of in lines that don't intersect, well, now we get lines that intersect to form a what?
A right
A
angle.
right angle. It's almost the exact same thing. It says, given a line and a point not on the line, there is only one perpendicular line going through that point. So where's our drawing? It's flying here.
Yeah, it's going to be all together.
Oh, so it's all together. It's okay. You can see the point kind of right above the package there. And, you know, in order to do this, guys, you can only make one line that's going to make a perpendicular through that line and through your original line. So the original line is the one running horizontal across the screen. You draw that point in there, and then there's only one line that'll run vertical that'll actually be at 90 degrees to that original line.
Yeah, same thing. After you see the diagram, how could you draw another line through that point that would be, it'd be at some other angle? There's no way it could be at a 90. It would have to be that line. So there's only one.
It's a Highlander rule for perpendicular lines.
Yeah, you know, from the TV show. All right, guys, I know that's a lot to take in, but we will definitely practice some of this, and we'll practice the types of angles and so on a lot.
It might look confusing, but it gets easy.
It is.
We'll tell you more things to make it just a cinch, so just
Yep.
hang with it.
Yep, don't panic. All right? Okay, we'll practice this in class, and we will. We'll get the hang of it, so. Okay?
Ta-ta.